Hi everyone, this is Dr. Quarto, and I wanted to show you how to use VassarStats to compute correlations for the group research project. First, you'll need to enter all of your data into an Excel spreadsheet, and this shows you some of the data that might be in a fictitious spreadsheet. The only data that you see here are the results of the two questionnaires that a group of counseling students would have completed for this project. They completed a perceived stress scale that was comprised of 30 items. This scale used a Likert type format to assess the frequency with which they experience different types of stress-related symptoms. Then they completed a self-confidence questionnaire. This one only had 5 items, but it also used a Likert type scale, this time looking at how strongly they agree or disagree with various aspects of self-confidence. In this case, what you'll see are the scores in this row. These are scores for the first student that completed the questionnaires, the second student, and so on and so forth. These scores right here in these first 4 columns represent the totals overall for the perceived stress scale. This stress scale is comprised of 3 subscales: physiological stress, emotional stress, and psychological stress. 10 items per subscale. And you remember self-confidence, there was just 5 items, and so we just come up with a total score for those 5 items. What we want to do is we want to look at the relationships between these variables. In particular, we want to find out if there is a relationship between stress and self-confidence. The way that we're going to do that is we're going to use VassarStats. VassarStats can be found on VassarStats.net. It might be kind of hard to see, but it's VassarStats.net. So go to that website, and you'll be taken here to the site, and it'll look like this. What I want you to do when you get to the site, go over to the left-hand side and click on Correlation and Regression. Then scroll down until you see Basic Linear Correlation and Regression, and click on Data Import Version. Next, scroll down to where it says Importing Data via Copy and Paste. Okay, this is important to read. It says, when importing data from a spreadsheet from Excel, the paired values of X and Y must be in the form of 2 adjacent columns. What that means is that the 2 variables that we're going to look at, in this case, we're going to start off by looking at the relationship between self-confidence and this type of stress, psychological stress. We're going to just call this, for right now, the X variable. We're going to call this the Y variable. Notice how they're right next to one another. They're in adjacent columns. Within the spreadsheet application, select and copy the 2 columns of data, then return to this page and click the cursor into the data entry field. So we're going to copy this data. We're going to do what it says. We're going to go down and click the cursor into the data entry field, which is what you see here. And we're going to paste that information in there. Now notice how there's a cursor here that's right next to 22. You need to put that below the 9. For some reason, VassarStats wants you to put that below the set of numbers. So these numbers that you see here are the same numbers that you see next to one another in the Excel spreadsheet. So we're going to compute a correlation coefficient between these 2 sets of numbers. The way that we're going to do that is we're going to click on this Calculate button here, and what you'll see are all these numbers that probably don't make much sense and that you really don't need to worry about. Really, the only ones I want you to be concerned with are this one, R, remember in stats that stands for correlation coefficient, And you remember correlation coefficients range from negative 1.0 to positive 1.0. In this case, this is negative 0.97. That's really a strong relationship between the two variables of self-confidence and psychological stress. And what we need to find out is whether or not that's statistically significant. So P, you remember, the probability value is what we use to evaluate that. Since we didn't specify ahead of time what the direction of the relationship would be between the two variables, we're going to use a two-tailed test to evaluate this. And in this case, it's 0.0002. Remember, in social science research, 0.05 is the standard rule of thumb to the minimum level to determine whether or not there's statistical significance with whatever kind of test that you're running. So in this case, this is statistically significant. So since this is a negative correlational relationship, what this means is that the higher level of psychological stress that a person experiences, they also tend to have lower levels of self-confidence. People who aren't self-confident will have higher levels of psychological stress. Those are related in that way. Okay, so we just computed our first correlation coefficient. Now, we're going to do some more correlations, but we need to get rid of this information here. And the way that we're going to do that is we're just going to scroll down to where it says reset. We're going to press that button and notice what happens. All that information that was there is no longer there, so we've made room for new data. Okay, now remember what happened is that we said that the variables, the values of x and y, they must be in the form of two adjacent columns. So next we're going to look at the relationship between self-confidence and emotional stress, but we have to make sure that this is next to this column. So I'm just going to insert a column here and copy and paste the self-confidence data here. So now it's adjacent to the emotional stress column. I'm going to do the same thing that I did before. I'm going to copy this information, go to VassarStats. I'm going to paste that into the data entry box. I'm going to hit the return key on my keyboard to move that cursor down here. I'm going to press calculate, and remember, we're only looking at R, the correlation coefficient, which in this case is negative 0.90. Once again, a strong negative correlational relationship. And once again, this is significant at the 0.005 level. Once again, it's significant. So now we go back and we say increases in emotional stress are accompanied by decreases or lower levels of self-confidence, similar to what we found before with psychological stress. All right, let's go up and get rid of this information here by pressing reset. And then we're going to look at the relationship between self-confidence and physiological stress. We have to create a column to do that. So go insert, and whoops, wrong column. We're going to copy the self-confidence data here. We're going to copy and paste that into data entry. Press return on our keyboard to move the cursor down. Calculate. Okay, now we have a lower correlation coefficient. It isn't quite as strong. Still negative, but not quite as strong. In fact, it's not statistically significant. So the relationship between self-confidence and physiological stress is not quite as strong as they were between these other variables. Now we're going to do one last correlation coefficient, or calculate one more correlation coefficient between self-confidence and the total stress score for students. And let's see if there's anything to this. Do reset to get rid of all that information. Paste the information, hit return, calculate, and there is a strong negative correlational relationship. That's really strong, like it was in the first case. Significant at the 0.0001 level. Okay, so now you've learned how to compute correlation coefficients between variables. In this case, we computed them between continuous variables. Continuous variables can take on a lot of different values. In this case, we used a Likert scale that can take on different values that indicate differing amounts of, in this case, stress or self-confidence. That's different from looking at a correlation between, let's say, a continuous variable and a categorical variable, such as gender, which only has two levels. Either you're a male or you're a female. Well, there may be more than that, but basically just male or female. And we just use those to essentially label what a person is, as opposed to a variable taking on different values, like in this case, stress or self-confidence questionnaire, or self-confidence. So in this particular case, the only thing that we were looking at were correlations between two continuous variables. In that case, we compute a Pearson product moment correlation coefficient. And that's about it for this demonstration. Have a good rest of the day.